Encryption isn't just a concept. It's something your organization uses every day, whether you realize it or not. From web sessions to secure email, from certificates to emerging blockchain systems, encryption is everywhere. As a security leader, your job is to understand how it's applied, what risks are involved, and how to guide teams toward resilient, scalable, and future-ready implementations. This lecture focuses on 4 key areas where encryption comes to life: TLS, PKI, blockchain, and quantum-resistant cryptography. When someone accesses your organization's website, logs into a SaaS application, or makes an API call to your backend services, TLS is the unsung hero protecting that data in transit. It's the protocol that secures communications across the internet and other untrusted networks. What makes TLS powerful is its hybrid cryptographic model. It uses asymmetric encryption to securely exchange a session key, and then symmetric encryption takes over for the rest of the session, delivering speed and efficiency. This handshake ensures that both confidentiality and integrity are preserved, even in high-risk, high-volume environments. You've likely seen the result of TLS in the form of a browser padlock, but your job goes well beyond that symbol. As a security leader, you're responsible for ensuring that your teams are enforcing TLS 1.2 or higher, that they've disabled insecure protocols like SSL and TLS 1.0, and that they're using strong cipher suites that protect against known vulnerabilities like beast poodle and downgrade attacks. You also need to look at certificate management. Are certificates being issued and renewed through a trusted process? Are your systems automatically rejecting expired, revoked, or self-signed certificates? You can't afford to let expired TLS certificates bring down your services or open up a window for man-in-the-middle attacks. And then there's mutual TLS, which takes things a step further. Instead of just authenticating the server to the client, MTLS authenticates both sides. It's especially valuable when you're securing internal APIs, service-to-service communications, or partner-facing portals where trust boundaries must be clearly enforced. Your leadership ensures that TLS isn't treated as a checkbox, but as a vital, continuously monitored control. You define policies around TLS configurations, certificate issuance and renewal, alerting on failures, and periodic security reviews. You also drive awareness across teams, developers, operations, and architects. So TLS is consistently applied to every digital service, not just customer-facing ones. In today's distributed, cloud-first world, data is always in motion. Your role is to make sure it travels securely, encrypted, authenticated, and verified every step of the way. TLS isn't just a protocol, it's a promise of confidentiality that you, as a leader, must ensure is kept. As a security leader, you use public key infrastructure to build trust into the very fabric of your organization's digital ecosystem. In a world where users, applications, devices, and services are constantly interacting across distributed networks, many of which you don't fully control, PKI becomes your foundation for enabling secure communication, authentication, and digital integrity. It allows you to manage public and private key pairs, issue and validate digital certificates, and rely on certificate authorities to create a system of verifiable trust. Your leadership in PKI starts with defining clear certificate policies. Who gets a certificate? What's the approval process? How long is it valid? Are certificates issued only internally, or do you trust third-party public CAs? These are decisions only you can make strategically, and they need to be codified into issuance, renewal, and revocation procedures. You're also responsible for ensuring that certificates don't just exist, but that they're actively monitored and rotated before expiration. A single expired certificate can disrupt critical services, break encrypted connections, or even trigger cascading failures across systems. Another essential part of your role is deciding which root CAs and intermediate authorities your environment trusts. Do you allow BYO certificates from vendors? What about external partner integrations? What's your policy on self-signed certificates in development environments? These trust decisions must be deliberate, governed, and aligned with your broader security policies. But PKI isn't just for websites and emails anymore. It's become the backbone of modern zero-trust architecture and automated DevOps pipelines. Whether you're securing internal APIs, managing mutual TLS between services, issuing short-lived certificates for containers, or enabling device trust in IoT environments, PKI enables all of it. Your teams rely on your vision to integrate certificate issuance and validation directly into infrastructure as code, CI/CD toolchains, and endpoint provisioning workflows. Even user authentication now leverages PKI. With technologies like smart cards, FIDO2 security keys, and certificate-based VPN access, you're replacing passwords with strong, cryptographic identity, making authentication both more secure and more seamless for your users. Ultimately, your job is to ensure that PKI isn't a set-and-forget solution. You need to build a system that's governed, automated, monitored, and scalable, one that supports the business without introducing friction or blind spots. When you lead PKI effectively, you create an environment where trust is built in, not bolted on, and where your organization can operate securely across every digital boundary it crosses. You've probably heard all the buzz around blockchain, but as a security leader, your job is to cut through the hype and understand the real value behind the technology. At its core, blockchain is a cryptographic structure, not magic. It relies on hashing, digital signatures, and asymmetric encryption to create immutable, decentralized records, meaning once something is written to the chain, it can't be easily altered or erased. That's powerful, especially in environments where trust is distributed or hard to establish. Blockchain is already being used in practical, security-relevant ways. You'll see it supporting supply chain integrity, where every step of a product's journey is recorded securely and transparently. You'll encounter smart contracts, which are automated, tamper-proof agreements that execute when certain conditions are met. And in the identity space, blockchain is enabling decentralized credentials, giving users control over their identities without relying on a central authority. Now, you don't need to be the one building or coding a blockchain, but you do need to ask the right questions when blockchain shows up in a project or vendor pitch. How exactly is cryptography being applied? Is the system using secure hashing and strong signature algorithms? What's the consensus model? Is it proof of work, proof of stake, or something else? And how does that impact performance and security? Most importantly, is decentralization truly necessary for this use case? Or could a traditional PKI-based system solve the same problem more efficiently? Your leadership role here is to make sure that blockchain isn't used just because it's trendy, but because it's the right tool for the problem. When applied with purpose, blockchain can strengthen integrity and transparency, but when used carelessly, it can introduce unnecessary complexity and risk. Your job is to navigate that line with clarity and confidence. Quantum computing may not be part of your day-to-day reality just yet, but as a security leader, it's your responsibility to anticipate the risks it brings before they become real. When quantum computers become powerful and accessible enough, they could break many of the cryptographic systems that secure the internet today. Algorithms like RSA, elliptic curve cryptography, and Diffie-Hellman, which are foundational to secure key exchange, digital signatures, and data encryption, could be rendered obsolete in the face of quantum-powered attacks. But this isn't a call to panic. It's a call to prepare thoughtfully and systematically. You start by keeping a close eye on NIST's post-quantum cryptography standardization efforts, which are already identifying new quantum-resistant algorithms designed to withstand quantum threats. These include lattice-based, code-based, and hash-based cryptographic methods that offer security even against quantum capabilities. From there, your job is to lead an internal discovery effort. Map out where RSA, ECC, and other quantum-vulnerable algorithms are being used across your environment. You'll find them in TLS, SSL certificates, VPN tunnels, digital signatures, code signing processes, and encrypted data storage. Identifying these dependencies now gives you a head start when it's time to transition. Most importantly, you need to guide your teams and vendors toward crypto agility. That means designing systems in a way that doesn't hard-code cryptographic algorithms, but allows them to be swapped out or upgraded with minimal disruption. Whether it's choosing libraries that support plug-and-play algorithms, enabling certificate rotation, or preparing your CI/CD pipeline to adopt future-ready crypto standards, agility is your safeguard against stagnation. You're not expected to be a quantum physicist, but you are expected to be ahead of the curve. Future-proofing your cryptography strategy is part of what distinguishes mature, resilient security leadership. You're not just protecting the organization from today's threats, you're ensuring that when tomorrow's challenges arrive, your systems, people, and policies are already a step ahead. That's how you lead with vision and resilience in the age of accelerating change. So, what's your leadership takeaway? Encryption isn't theory. It's real, applied, and mission-critical. Your job is to ensure that it's implemented correctly, governed consistently, and modernized over time. From TLS to PKI, from blockchain to post-quantum algorithms, you set the vision for encryption that empowers innovation, builds trust, and withstands the threats of tomorrow.